Okay, let's see here. I'm going to go over this battery design and the reasons why it can't really be used the way people might expect for it to be a plasma engine creator and so on. All right. Which a battery is a organic slash non-organic synthetic compound layered like we have for plants that use an electron gap to help create, which I have in several of my manufacturing designs for some of my more cool materials that work wonders for what it is I'm trying to do. But this is a similar thing where it creates a electron gap, or not gap, it's a good way to put it, with water going through, like plants tend to do with sunlight, which this one isn't going to be using sunlight. This is going to be using good old physics. Come on, Phaser. So what that means, Phaser, come on, is that flex light and where it is. When an electron is ripped out of its orbit, produce a little bit of light. And so with the right material in that and a amplitude uh, necessary, truthfully, but you know, better way to put it is, you know, holes. Well, kind of. So the way to put it is, it's a very, very empty, almost aerogel style of, but not battery. And so what that does is it allows air to go through. As other extraordinarily useful because they are to on state that can be used to contagious electrochemical reaction for our purposes, electricity and heat. So skip the reflective and amplify whatever, you know what I mean? Think about them like tubes that are undulating, kind of like our intestines. Now, they have grooves and slots, which means they are polarizing themselves as they go through the tube. Now, see, this tube happens to create what is essentially wave guide to the light contained within it. But we don't really care about the light, except for the light that's emitted by the electrical gap creation. So, materials with a fair small amount and degree of light will do this. They tend to be better at it and they have more light, but it's a runaway chain effect because electrons are going to be not what we have to concern ourselves over. The separation of the chemicals going through. The electrons are going to deposit themselves into the surrounding material. The light then reflects and effectively creates a waveguide. It then separates because the electron did not come back into the chemical, making it ionic, easier to separate. just any easier to separate. With the proper this spin imparted in the wave with those grooves and slots, and polarizing function happens to introduce a area effect for the chemical and its electron orbitals to be moved, jiggled, and ultimately given a very significant amount of push-pull for the electrons that are attached to this now ionic size ionic chemical like carbon dioxide or water or other pollutant compounds. Now, as a result of water not some people being very, very prevalent, more pollutants might be there, smog and it's a balancing act here, okay? But what we found with these compounds attached to the, as I've stated in my previous YouTube video, which I'll find and link, I can get this put up on YouTube. It's a series of really good combos of essentially like iron. We used, let's see here, potassium. We had a few fair degrees of calcium that we wanted to try. Calcium didn't really work too well. Tend to break down with the heat created as it goes through. There's a way to basically make a better version, which is what I put out. I just don't remember what it was now. It's all there though. So, but it's like, you should remember, and I'm like, I don't remember all 118 darn stupid elements, nor do I remember every single on up, down, bottom, farm, whatever garbage. It's a lot to remember. Come on, Phaser. Come on. Yeah, I just don't. And I don't think many people do that either, that are like me, who are kind of, in terms of science and physics and so on, interested in many different fields of study. Come on, Phaser. Come on. He's just sort of sitting still, barking. It's okay. It's okay. It's okay. You don't have to be carried by me. Anyways, silicon doesn't really work very well. It's kind of manganese is cobalt. I used that for another one, if I'm honest, which was supposed to go with my spacesuit. Put out there already. So now, knowing about that, the silicon doesn't combine the way that allows for those electron orbitals to actually break off in a manner automatically with just a little bit of light, which shine through your car, radiator, so on. So I tended to do is put organic compounds and then strengthen them with because I either gave them positive or negative depending on how I had to manufacture and layer it. But we're talking plant compounds, like literally plant compounds. But the thing is, those compounds are really ridiculously tough. Like they're fucking pretty tough. So when I was like plasma deposition at a low temperature, you know what I mean? I have a layered substrate that is a negative whatever thing, and then it's like I blast it with the charged, bath of argon and these compounds, that in a very specific phased array screen, more or less, that has a degree of electromagnetic and light, that being the lens and the light that goes through, and then allowed for the charge to be repulsed and fired faster than detected. Come on, phaser. Come on, going this way. Now, that plasma deposition means that I have increased / decreased, depending on the type of plasma, and some electrons. And it's trying to get rid of them. So if you have a negative, it will then add it to it. So what I found is that like these plants do this for sunlight. And so if I use the right laser to push it, along with an electromagnetic push, and then the right diaphragmatic air push, pulse, set up with the right screen, incredibly alignment and laminaring of the given laser. Come here. Come on. What's going on, Fluffy? Fluffy. Here. Yeah. All right. Laminating of the charged compounds with the gas that is very unreactive. So you don't charge the gas compound. You just have to have it in gas. It's neutral enough. Doesn't allow for it to ultimately create for the laminating as a result of repulsive charge forces. And too much potential energy gained over the speed and distance it's traveling, because exothermic reactions can start to occur as a result of that. If you do it correctly, with the correct cooling and all the rest of it, corralling for luminosity increasing thanks to the lasers and air pulses with the diaphragms and the electromagnetic pulses that can come on, phaser. Then I allow for it to effectively create a very, very, very fast depositional state that combines it in midair, then deposits itself onto the substrate. But then I use a substrate that is meant to make it appear to the plasma that it wants to go there, which typically means it has more electrons. And so it'll head that direction, and then I use the correct charge fields and lasers to essentially allow for it to deposit itself together with the combination of this material to layer it appropriately down to incredibly accurate finite degrees of extreme precision and consistency. So I can now make what is literally perfect kind of in a vacuum. There's always some level of noise in the chamber, from my understanding. But really, really high, precise, 1 nanometer in length, degrees of precision and accuracy as a not 2D structure, but it acts like a 2D structure because of how it crashes out. And then once I can do it again, which typically means creating incredibly accurate 3D printing additive designs, layer by layer, and it's fairly fast. I think, the highest heart rate, I think gigahertz for like a CPU 5 gigahertz. That's about half, maybe a quarter we could feasibly do for how fast we can deposit it, because of how fast it cools off and ultimately layers and still heat there, but typically is okay with the heat that it's going to have, as long as we're not talking within about 100 years of material. It tends to dissipate fast as IR or something else. if you run a little bit of a vacuum pump, the argon itself becomes coolant. So that one's a nice one. Then, while it's cool and everything, it's just to explain why these compounds survive. The compounds will stick to the necessary areas that make the sunlight turn into an ionic electron rip, effectively. And what we've seen is that all they really do is make a very strong charge field. They emanate from them by layering themselves appropriately in their structures for their cells that are producing this. So in a small little area, you find like a little bubble, a little circular spear-ish kind of thing that has some lenses on either side that seems to concentrate it and then filter it. And so as a result, which is proteins and basically those organic compounds. And so it would appear as though it interacts with light to produce a charge field, which we actually see this very effect. I was talking about earlier today, actually, with this plastic compound that a NASA scientist who wanted to make his own bicycle-powered, human-powered flight, plane. And so when they aligned that same plastic he made that out of, and then they had a secondary one underneath it that happened to be perpendicular to the alignment of the one above, it interacted with waves. I remember this because I was watching it on the Science Channel. I was high at the time, and I understood perfectly. Really fucking amazing, honestly. I was like, what does it use? Turns out it creates a charge field that will deposit itself into an electromagnetic elongated field. Kind of like our Earth does with its, everything, basically. Phaser. We're going this way. Come on. Phaser, come on. Phaser, come on. Come on. Anyways, that charge field basically turns into, it breaks down, there's a chirality, meaning a vortex spin that it seems to only do as a result of destructive wave interaction forces that tend to be now, because it was vertical, or whatever, because of the alignment, meaning polarized in a very particular way. And then phaser, no. God. They created very simplistic charge field interaction after it got hit by the opposing alignment of a lens, essentially, of radio waves. And then, because of the wave interactions, canceling some of itself out, but then creating pressure, like pressure, quotation marks, real quotation marks there. They call it something else. I look at it in a thermodynamic way, where it's like, it's making an electron, not electron, a charge field, but it's not a charge field. It's literally a constantly flipping charge of positive, negative, and then makes positive and negative in very specific areas. And if you look at it, it creates like little bubbles, kind of like hydrocarbons burning inside of a jar that seem to appear and then move down. But that's because light's moving that way. It's not just appearing. Light is light, still there. So what it means is that the light wave created a spin, but it's not really a spin. It's more of like a barrel roll, corkscrew, still tracking the same alignment, meaning polarization, whatever you want to call it, but then it slowly wave destructs itself into a charge field. And then it interacts with our atmosphere or whatever else. Told you, phaser. Told you to be careful. But, well, there's no material. They worked in they work in a vacuum. But uh, I can't wave into a charge. But the charge is a charge so much. Well, kind of there. Just to say, it's there, but it's not a technicality. It's there. It's like, hey, superposition. Which is how the light wave interaction uh, combo, meaning merging of light waves that are not destructive instead of amplifying, tends to happen and work. Phaser, come on. Okay. All right. So, which we actually use in phase arrays. So that's why it's like a thing. It's real. So, anyways, the light waves interact with themselves in a non fully destructive manner. And so apparently, as they go through, they create a rebounding information, not paradox, wave fluctuation that collapses into what is effectively just, I need to be turned into something. I think I have energy here. So, but they resonate themselves. Phaser, come on. Stop running backwards. You scaredy little puppy. Jeez. Alright. Anyways, as it spins because of the light wave destruction on either side of it. And remember, light is everywhere. You know what I mean? Tends to mean that there's a fairly strong degree of higher amounts of radio waves on one side, tends to push that other light that's lower amounts of radio wave light back against itself. Sometimes it cancels, sometimes it doesn't, and it combines. But the point is, you find a boundary layer in its interactive field, in its wave function area as well, quantumly speaking. Now, as a result of this, what it ultimately amounts to for you and I was apparently, because of the weird resonance of the fluctuations, the wave fluctuations, and the charge fluctuations, which started to occur once it started to have some charge fluctuations. As it builds up, it started to create a version of a spin. Now, spin is relative. It can't create spin. It's not going to create spin. So instead, what does it do? It has to corkscrew, which is not spin. See, spin is the individual photon spinning. This is corkscrewing. Yeah, which is a bit weird because then they combine and they collapse from outside in. And let's see here. They go from rather short corkscrew to a rather distraught, weird, spread out corkscrew that's kind of like waving in its own right. Now, the reason why they posited this was because of diffusal interactive forces. Meaning the light's still there. And of course, creating an charge field, it then ultimately ends up making some light along the way, which seems to be very specifically aligned and creating an interactive pressure field, more or less, that destroys inside and outside, creating a resonance down the corkscrew and up the corkscrew. All right. Now, this corkscrewing is not really something new to us. they're talking about it being a large chirality field when it's actually really not. Like the corkscrew is the light. The field is after. Come on, Phaser. Come on. You go over this side? Come on. This will learn how to freaking follow me. Don't be afraid. Alright, now, this field of light, essentially pressure light, which, I mean, that's how I view it as. Light does have a pressure on itself, or more often than anything else. So, it doesn't create bells, it doesn't create columns, it doesn't create really much of anything other than these tubes that are corkscrewing, that are weirdly resonating with inside of themselves. At least that's what their papers suggested they do. So, again, these are all lots of things that basically say, hey, so this tube barely exists, but the way it exists, it super makes sure it exists. It's interacting so hard with itself, and a resonance frequency with inside the corkscrew that makes it basically then destroy itself, like fraying at the ends of the tubes. And then that appears to be like a shower screen in its own right, that then has a massive amount of field charge, more or less. It has to break down this field of very highly potentiated wave functions, more or less, that are no longer light. They can't go back and being light. They're not able to dump the energy and interact with it to make light, although there's still some light, but it's mostly can't do that. So tends to make charges, a excitation of those fields collapsing into positive and negative, or a switching of the two charge fields. Now, the switching of the two charge fields is a really relative way of describing it. Basically pops in one way and then interacts with something and then drops out. That's making the electromagnetic long wave function, which seems to be propelling it forward, is what some have hypothesized. I say it's a resonance frequency that's within inside of the electromagnetic wave that tends to potentiate itself moving forward by pulsing in the electromagnetic wave field, because it's quite aligned in its spin and then focused in a tube-like kind of field way fashion, and it's now spun together in a far more cohesive fashion. And so then when it pops in and it does that oscillation, it creates a wave of electromagnetic possible potential that then crashes out. And if you go over their results, it's still an inverse square or cube. I forget which one of those. Point is, it's an exponentiating drop. But the drop is much further along. So it still goes far of a distance. But that distance, okay, is once you shrink it, the numbers in between suddenly looks very much like an inverse square law. The result of this, some people posit that it's traveling fast at the speed of light, or at the speed of light, which I'm like, electromagnetic fields already travel at the speed of light. So I don't think that's what it is. And that's me to go, probably its frequency that in the field itself that then propels it along and then loses energy after a certain point, and then it has another resonance frequency, which is lower frequency, and another lower, until eventually no longer has another, captured within the electromagnetic field itself. And then they were like, this is something that we could really, ooh, yeah, cool, right? And what led to it really being anything was, I told you there are electromagnetic fields and nebulas and galaxies. I told you there's ginormously large fields in the entirety of the universe. And I'm like, yeah, because they couldn't make anything out of it. It's super low energy, even though it travels a very far distance. It's effectively just an alignment thing, and it can barely interact with any kind of light and even charged particles. So it essentially means that it's kind of like a lasering of and a resonance frequency of light, which we have actually done with phasor arrays that have the correct phasor lensing to situate themselves between another one in front of it and another one in front of it. And so it would maintain its focus, alignment, laminar, whatever they call it, something to do with, all going one way, wave frequency stuff. But like to me, I go, whatever, it's an amplifier, and you just send it further. And then they were like, we can do this better. And this was in the 50s for apparently satellites that they were trying to use for the military. So there's that. Come on, to trying to extend and reduce the crosstalk or possible talk getting to the enemy's ears by focusing it more precisely. Now, Phaser, no, that's barbed wire. Come on, damn it. Now, what we found out was if they simply allow for a array in front that allows for a regular non-arrayed source of radio waves, it would then be able to be phasered but amplified, and they did it with the correct pulse from those phaser arrays before and then after. It seemed to create elongation and a focusing like a laser to radio waves. They haven't ever really needed to use it for a very, 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 very long time. Who cares? It's effectively kind of worthless. We have better technology that goes way further, carries more energy, has the ability to send more information through it. So by the point in time, they figured that was a thing they could do. So it kind of went the way of the dodo bird, much like the pill nuclear reactor, as I like to call it, that Bill Gates is trying to do, where it slowly but surely uses up the entirety of its slug over time, that then makes a good amount of energy, like a pill. It dissolves. Now, that is all to say that it's like, this is understood physics already, okay? Already understood physics. But, like, not everybody kind of has, because they have no friends like me, they have, like, no other things to do, constantly watch and listen and read tons and tons of science articles and documentaries and stuff about random niche topics. And so that is, anyways, to me, it turned into, well, actually, we can't really use this for anything. There's another version, but then it was like, oh, so that means that's why we're seeing those charge in that direction. It's not always gravity is electric. Starlight interact in a way that the is like kind of like light reflections, collapsing wave lines over time Of course, there's various effective within any galaxy. So that and so seed and then so hydrogen, you know. Radio kind of trained to so to me, well, looking at this, at my I have my headphones on. Like there are people, they probably heard myself saying grenades on this microphone. Doesn't be bad. Better not be right. Anyways, now look at the effect that we have here for these organic compounds. They happen to create basically a very similar effect, but it's just down to charge fields that make very powerful attractive and pull forces, respectively, and a elongated from the lenses electromagnetic field. When they combine, which isn't very elongated, it's pretty small. It's the size of, plant cells. So, very strong, but it does its job. That's what it's for. And then they usually have other compounds that help create an electron reduction in their orbit that allows for the organic compound to act like a catalyst, potentiating effect. So, as a result of that, and the fact that they're kind of meant to handle a lot of rough weather, light never-endingly hitting them, and they usually can repair every so often, they tend to last for a long time. What I found is the organic compounds that allow for electron excitation, and then flipping, and then, well, not flipping, it's rip off the orbital, but then it sinks into the ground state that is the compound in here that then to return to the or compounds, creating its own version of flow battery that creates a almost quantum engine. Much like that one dude who's like, oh, so I basically broke this dude in the 18th century that was like, make a quantum engine or any small engine to make at all. And then he was like, watch me, I made a 4-stroke engine with an atom. And so, yo, these people, boys, those hey, what of them? They're over here. But those people weren't able to tiny structures, which have been Chinese. Oh, wonderful. All this. Well, before evolved. With that, there's that. Anyway, hey, I tried to walk a little distance, but I got scared. Hey, this is my puppy, hey, Spacer. Yeah, he's a cutie, but he's
Hey,
when he's alone
stop!
with me in my
Stop!
apartment, he tends to get a little aggressive on the biting.
Yeah.
But otherwise, he's pretty cool.
You gotta socialize him. Hey, stop.
Yeah.
Isn't he beautiful?
Yeah, I know. You'll get big too. All right, I gotta go in. I'm also kind of tired, so. Yeah. Nice meeting you.
Beautiful puppy.
Yeah, thank you. Nice seeing you guys. The bite this point. My foot. I have apparently degenerative arthritis in my feet, as my periodontist, whatever that is, happened to diagnose me with. So it's not like, oh no, I didn't get this. No. I diagnosed myself. It was like, no. He's like recommending cutting into my bone and my feet and shit, and I'm like, I don't want to really do that. So that's a thing. Anyways, it's a lot of work. I have to pee. Just a second here to pause this pee since you don't have to hear that and kind of stuff. All right, so where did I put my other glove? There it is. Okay, so peeing has already happened. I need to get some water. So the basic premise is that like plants can kind of make a little bit of electricity, except not really, because their skin and membrane and all that can't really handle that. But the compounds inside the cell can handle extremely high temperatures and high degrees of radiation. And that was kind of what I was driving at. And then I needed to explain my thoughts and hypothesis and what I'm aware of, that the studies I've seen happen to say that these materials happen inside of plants happen to do this thing. And there's a wonderful tweet I made on my Xenon Reality about this very study not too long ago, a few weeks ago at this point. But I predicted it back in the mid 2010s. And so I was basically vindicated by a study that passed a lot of rounds on YouTube, even, where they talked with 2-Bit Da Vinci, a YouTuber, that happened to talk very much about this very effect too. And a couple others, I'm forgetting which ones. But I remember it in my subscription feed. So there you go. But for me, it was like, these can handle pretty high heats. Like, not to pry too much, but into that. But as long as you keep it under a few hundred, like, let's say 200 to 300 degrees Celsius, sustained over a duration of about 30 minutes, they'll stay together. Gamma ray will allow for them to break apart after about 5 minutes. Plasma, like we're using, that crashes out and elicits a large degree of IR, microwave radiation, and some regular light that we can see, and a little bit of a higher frequency UV slash nothing really gamma ray, but X-ray, which again, it's super minimal. And the chamber I have for my design happens to reflect that. So first and foremost, it's a chamber within a chamber. So as it goes through the first cage chamber, it then polarizes quite a bit for those higher frequencies and lower frequencies. Then I have them interact in the space in between the reflection chamber. And then that reflection chamber then interacts somewhat with the light coming still towards it, but then also back towards the cage chamber, which then allows for also a slight degree of reflection from it as well. And so once the first goes, you pulse it the right way, it then cancels X-rays into, well, not X-rays anymore. Tends to make them very, very specific white light, a degree of very low range infrared and mid-range peaks in pretty much our normal visible spectrum, with a slight uptick in purple, which is a blend of red and blue. So, but that's with my cage reflector design that I created back in the mid 2010s. And so I had time to kind of like just meditate and think about it, sort of like space by space, piece by piece, second by second, individual interaction by interaction. And so I brute forced it and what it should do based upon what I understood light wave interactional collapse tends to also do with diffusing. If you do it the right way in the right areas with the right geometric shape design for the reflection in the cage, those interactional diffusal areas are actually now a fairly significant filtering-ish slash not necessarily lensing. They sort of interact and collapse into a directionality, sort of like a lasering. And so I called it back then lamineering, because that makes sense to me, because it's a bunch of photons, and while yes, they are waves and they interact in a wave-like fashion, they're still particles. So, and with fields that interact with each other. So I figured it was not a bad idea to kind of like make that properly oscillate by having the right sequence of depositing events for the plasma and charged compounds. And argon's a really good one because it tends to absorb very strong types of high frequency radiating light, like ionizing, like gamma ray, X-ray stuff, but not fully. Okay, it's a little reduction, slight. You know what I mean? So I figured not a bad idea, and then it's fairly dense as a physical atom, and but then it's also not necessarily trying to push through. Let's not go with push through. It's not trying to absorb a lot of light. It's just meant to absorb a kinetic energy, heat. That's what it's meant for. That and the diffusing and everything, it's just annoying to have to deal with when it comes down to layering. Again, we can usually hit a meter within a few hours, typically. But you can do it faster, but you're probably going to have it a lot harder to meet certain specificity of targets for like nanometer size ranges, alongside of the compounds not breaking down quite as quickly, which is a big plus, if you don't do that, because that's kind of what you kind of need. But then I also use synthetic compounds. Iron is not a terrible one when you dope it correctly with the right charged compound, like a potassium. And then we used basically that combined with those other compounds uh, that forced the effect to be much more pronounced, but also make a far better electron flow battery. So what we found was, or at least not what we found. That's apparently. I keep saying that because it's like I've heard people use it so darn often. It's no one else but me here. But it's like what I posited in my head was, well, so potassium in its own right will, when compressed, and has charge fields that allow for electrons to be aligned polarly and spin-wise, together with iron, which appears to be a really decently strong magnet, tends to potentiate its electron coherency in the pressure wave of the sine wave that goes through it, because we use a flow current, which I've talked about on my YouTube channel, with quite a few different videos, and then also with my stream on Twitch. And so the compound, or not the compound, but the alignment and everything tends to mean that the electrons with flow current, which is as I described it previously with, on my Twitch stream, is a sine wave that we create a jiggle, which is a wiggle, which is up, and a jiggle, which is down, which means a sine wave within a sine wave. But then we pulse that very specifically as it goes over its regular sine wave. And now see, jiggles are annoying, but wiggles are easy. Ups are easy, downs are not so easy on a regular sine wave, which is, let's say, 1 kilohertz frequency. It goes up, then it goes down, it goes up, it goes down, it goes up, it goes down. Now we're going to create an up, and an up, and an up, and an up, and we allow for it to travel like a regular sine wave. That produces information for our electronics. That's a 1 or a 0. But it's also preceding the sine wave itself, which in its own right is its own 1 and or 0, which I never really specified during the stream, but that is also a version of a 1 or a 0. And there's a 0, completely neutral state, and a positive 0, which has not gotten to the point where it is, to a layman's way of putting it, an energy level, which means that it would be considered previously as a not neutral. We're talking about a degree of noise that they account for in a bell curve of data. Now, that's a real layman's way of putting it, because it's actually, there's enough for electrons to pass over any transistor at a positive 0. But it usually means that the electron tends to have some type of effect to it that we don't measure properly, or if we do, it might throw off the result or something like this. So we tend to use it as a noise, because there's not enough oomph, I guess, or something that makes it so that way, like, it's a known constant value. The problem for me was that I'm like, nah, transistors can absolutely detect that perfectly. What's the problem? We're just going to use it as a 1 or a 0, meaning it detected it. Morse code versions, dot, dash, dot, dot, dash, that kind of thing. That's all that is. So why? But that's how they run silicon transistors. So I don't really know why that is. That's just what I'm aware of them doing in the 2020s currently. I'm in 2023, so yeah, it is. But apparently they didn't do it that way before, and they had an entirely different version, which was a weird super DC coherented instead of sine wave. version, but that's how they get these faster speeds out of their clock cycles. Anyways, I want to move off of it because it's like we're just creating a wiggle and a jiggle. And so like a wiggle and a jiggle, when done appropriately in a sine wave, okay, allows for the electron flow to pop up and then pop back down. But then it didn't really pop down, it remains as normal on the sine wave. And then it goes back up and it goes back down. Now the electron on the opposite side, somewhere else, has the chance of going in. But where it pops back up, it creates a reduction in that electron in its orbital. Okay. Now, that's wonderful actually for the organic compounds and the synthetic compound, which is apparently a, whatever I stated it was, which is such an annoying thing. I mean, I just kind of put it together really quickly. Let me just get my periodic table of elements. So we're on the right side. So let me see here. Where did I put this? That's not the right thing. Okay. So it should be here and there. See here, fluorine, phosphorus is what I believe we can go with. I forget what the heck S was supposed to be. Darn it. I think it's sulfur. Oh, yeah, no, that's what we did. That was sulfur. Yeah, sulfur was so much easier. A sulfur, let's see here. Sulfur, shoot. Is that boron? Yeah, we couldn't use boron. I couldn't use boron. Sorry, not we. I couldn't use boron because it just doesn't like to stick very well. And fluorine was a, ugh. So phosphorus was kind of out if I used sulfur, and so then I looked at beryllium with the potassium with a basic magnesium compound, which did fairly well, but it broke down after a certain point, and so fluorine, which is just before the F, just before the neon, with sulfur, beryllium, and that was it basically, because it would connect with the potassium and the iron and then the organic compounds in such a way that it made it very, very stable, like a really stupidly, obtusely stable compound, like a forever chemical. And that's just because of how uninteractive it created this elongated kind of chain of compounds was. It's a nano-sized, really high current flow compound that happens to have one side be extremely good at making charge fields that are extraordinarily aligned, and then a stupid amount of reflected IR and regular normal light that would go through this and then create the spin electromagnetic effect, which usually meant that it would create a ionic style of interaction, meaning it to the water, carbon dioxide, and so on that came through would appear as though it really, really needs an electron, even though it has an electron. And so, but the electron is technically there. You see, it's just connected on another point. And so it's there. It's just not always seeming to look that way. It's a nice little trick of the light. You know what I mean? Like I have it's a smoke, magic, and mirrors in the quantum realm, or whatever atomic float your boat phrase is, but essentially it's like, no, I'm not here, but actually I'm there. That's what that is. And all it really meant for any of these chemicals coming through in our air, it would first off align them fairly decently, because it has this kind of electromagnetic property to them. It's not very strong. Um, it's mostly just the fact that it created, with the shape and design we had for the substrate and everything, a pressure wave. That meant that the pressure that was in the boundary layer that would slowly go in would basically create a spin and a alignment to the now kind of projected a little bit outwards permanent magnet field. And then electromagnetics would get into play as the permanent magnet would switch to an electromagnet, and then permanent magnet, and electromagnet, and permanent magnet, and electromagnet. But in so doing, it left a field that oscillated in between and then creates a slightly elongated version of that field, but it's not very powerful and it's not very long. It's just situated in the boundary layer. So, but a little bit goes a long way. It improves a little bit of efficiency, and just nothing terrible about it. It's really just the fact that once it rips an electron, it tends to create a bunch of photons more often than not, and a good degree of electron movement, which then creates a potentiation to kinetic, which kinetic was handled by a piezoelectric that sat in between other areas of the synthetic organic hybrid compound. Which, no, I did not tell you about, but I was going to get to it. But I talked about it on my previous YouTube channel. But it's effectively like just built upon that, like as a substrate, but it's not really. See, that's where that whole caveat nature comes in, because it's like, well, if you just layer it like that, and it's like, well, so no, I can't. So the piezoelectrics is a part of the battery, and meaning it has its own actual charge. This creates its own version of a pretend charge, but then actually creates a very significant change of fields and uh, lack of electron on one side and another, and it keeps switching constantly. And let's see here, then the air itself, once ripping off an electron happens, creates another version of the same thing. And then we have the fluid, that's correct, that I forgot to mention that cools, which actually I mentioned earlier on this, I think. But the point is, it's a refrigerant coolant that's very similar to a like a potassium, where it has a lack of an electron. Typically, I don't want a lack of electron, but in this case, that works very, very well with those piezoelectrics, as they tend to have a extra electron because they're usually jiggling a little bit on something. I mean, it's supposed to go in a car, so it's like a little compression and all that, but it's like, hold your horses, because with that fluid that we have, that in its own right creates a battery that will go through and then rejoin back into the compound that's in the iron. Okay, through the piezoelectrics, which tends to make it heat up and then cool off, and it elicits IR, an electromagnetic field, and so it creates its own version of potentiation. Now, it's not going to go forever. There's no such thing, and in fact, it doesn't go for a very long time. Okay, so for anyone out there that's like, and it's like, nope, 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 no perpetuals here. No. There are no perpetuals. Don't think I'm trying to sell you on a perpetual. It does, though, introduce some level of gain back because of the electron resistance. And so when we layer it correctly and have them interspersed correctly, it gains a advantage to areas of oscillating electron resistance. And as a result, once we add in the proper field effects with the electromagnetic and charge fields, it allows for electrons to flow very, very cohesively and with lower resistance outside of norm. So once it starts working, it then makes it much better to work. And its efficiency is rather high, and that's another reason why it also happens to have a very significantly huge capacity. So as I was riding my bike here, I was talking about it, but like a standard lithium, let's say 2 kilowatt, screw it, like a kilowatt battery, just kilowatt, because simple math, easy, is now more of a 1200-ish kilowatt. Except you have to remember that it is also not the same size. It has to be less dense, it has to have the right hole structure, and it has to be able to be wide enough to allow for the air to go through appropriately and layered appropriately. And so as a result, it's like we gain this, and it's the same weight, but it's not the same size. That's what that is. Okay, and it actually needs to be a little thicker and a little wider than that, 1 kilowatt size battery pack typically will end up being in terms of flat packs here. Okay, so that means it takes up a little bit more size, but the weight is good, but then the charge is phenomenal, but then the charge is not so phenomenal once it is lowered in size because it doesn't gain these efficiencies in terms of being able to allow for electrons to flow. It creates its own version of a supercapacitor that dumps itself into the battery itself, and then that in its own right creates heat that it tries to recapture, and then it kind of goes on, but it also makes electrons that are, or not makes electrons, but has electrons more often in one spot than another, and those are always trying to get it, but then they'll skip off because of that decreased resistance. Instead of staying there, they'll be grabbed by the compound that's in the inside of the iron, and so we'll go back. They will stop and stay in the other compound that wants the electron. But it takes a while because piezoelectrics are creating more electrons, and so are the compounds with the organic synthetic compounds, as they sometimes will interact in such a way where a photon will actually create an electron. It's rare, kind of. It's very specific areas, and it seems to be more as a result of the organic compounds. But that means that it's a fairly powerful battery. But we also have the air, which is chock full of some water and carbon dioxide and nitric oxides, and then that creates more heat and more electron flow. And now that electron flow, which is in this liquid, the refrigerant liquid, it goes to the version of this solar panel that I designed, which now that I've looked at some of these other studies, there's this higher efficiency photovoltaic with a perovskite design that happens to have this very electron band gap catalyzer refrigerant that, when layered, as I was talking about earlier this morning, although I didn't record it, I should have recorded it, but it's that plastic I was talking about earlier. Okay, so that plastic can go on the surface, and so that surface is patterned to be like checkerboard, and then the inside that's inside the square of the checkerboard has divots, and then those divots are like a U, shaped like a wave shape, fullard, but they're horizontal. Then there are little areas in the inside of the divots that are horizontal, that are vertical and placed perpendicular, meaning to the horizontal, but they are inside of the um, solar panel, solar photovoltaic areas that are there. You're not going to see them, but if you break them apart, because it's a multiple layer structure that uses the ferroelectric material that we now have, which is freaking wonderful for this catalyst refrigerant that we're using, which increases band gap by supercharging it. We're not getting something from nothing. See, it's taking electrons and allowing for those and the photons to create a catalytic moment to allow for an elicitation of more electrons by decreasing this overhead. But then it also concentrates IR in a given area. But now we have this IR increased photovoltaic 200% and ferroelectric and all this stuff, which basically all this stuff amounts to, as it comes in. Thank you for anyone out there that's listening and has gotten to this point. I appreciate it tremendously. But it comes in, it then has a shoot. Yeah, no. So let's walk back first. Okay. So the solar photovoltaic has that plastic on the top, but in between there's a layer of this layering, and just like our battery, where it has holes, it's like a filter for photo amplification, kind of like night vision goggles. So night vision goggles will usually amplify and have a certain wavelength that it does it with, and the compound will eventually degrade and you can't use it anymore. But when done appropriately, it creates a longer lasting effect even in the direct sunlight, especially with the cooling we now have. And also, it allows for a coherenting with I call it like this, a version of a Tesla valve for light. And so it has a two-way mirror, which one way it reflects, the other way you look through, but it's interspaced in the Tesla valve kind of fashion where it is bent towards the tubes. Now, for certain wavelengths, this compound, that is amplificatory compound, which we do use for night vision goggles currently with the military, which typically uses IR and then amplifies regular light wave, normal vision light waves, and then wave interacts and cancels and amplifies those wavelengths, or simply just filters it with some electricity to display it onto a screen that they have by detecting that light. So, as a result of this, technology for these military night vision goggles, we can use the same idea. This allows for light to pass through that we want to pass through, and light that we don't want, it will interact and amplify. And coherent and laminar, meaning laser-like. But it then will reflect interactively towards its center, and then down, and then up. We interspace the two-way mirror with the light amplifying compound. And so if you do it with the correct layering and the correct side-to-side spacing, side-to-side, vertical, that kind of thing. So a good way to put that is patterning it with slightly offset holes, but in such a way that if you look at it right, it will not look like the holes are there,
But if you slightly look off, it seems like there is holes there until eventually it almost looks opaque. But that's fine because that starts as a lens to curve those other wavelengths from larger degrees of angles into interactive forces for the light that we need, and or into the reflection at the bottom. So the reason why we have the patterning of this solar panel like it is, it allows for light to break and become polarized and interact and reflect in a very cohesive fashion and pattern. So it goes from side to side vertically and spreads out side to side and diffused diagonally. And then we have longer wavelengths that have this backing, which now, of course, has our refrigerant and band gap increaser, which isn't really, it's just supercharging and makes it operate at its peak, just tends to help it along. It's not really gaining it, it's just supercharging it. It's like when someone calls an engine that's producing more power with a supercharger a more efficient engine, it's not. It's just doing a lot more because it has more air and fuel. So effectively, same thing. So that's what that's for. Okay, now, but that refrigerant also elicits this IR and natural wavelengths and some microwave. And now other wavelengths that are longer, like radio wave, microwave, Wi-Fi, short, that kind of thing, and then IRs, and then very, very high frequencies like ultraviolet, X-rays, and even some gamma rays are captured and then interact in the reflection area and alongside of the tubes that are filtering and lensing towards the solar photovoltaics, amplifying again the wavelengths, but it's not wavelengths, it's more the photon luminosity that they have. And so as a result, it gives them more opportunity to interact with the solar photovoltaic. There's more photons to do it as well. And consequently, we also gain heat, which we're cooling it with the refrigerant we have, which then goes into my other refrigerant or waste heat generator. So it's a refrigerant that's not really it's not really much of anything other than a regular refrigerant, if I'm honest. They already have ionic refrigerants that they use currently, and they aren't really harmful to the atmosphere. They're just usually not used because of their propensity to be kind of not as good as a refrigerant in terms of, this is rough to say, but it's because they're really stupid in terms of the amount of compression and the overall heat that they are able to resultively, upon expansion, get rid of. And this is perfect for us, actually. We're not using it as it's intended. We're using it under compression as a thermal siphon, and we use a basic pump, like a literal, just really simple pump, not a compressor. It's just a really, really high efficiency pump. That's it. Yeah. Anyways, it, upon expansion, pushes the rest of its vapor into this radiator, which the radiator is a standard. It has a reservoir on one side that spreads it out, and then it spreads it into a bunch of, like an air-to-air intercooler lines, flat lines. Okay, so not flat though, but they're teardrop kind of shape. But we don't want teardrop because then it tends to not be super great for air resistance and ultimately the time for it to exhaust its heat through convection and all that into the atmosphere. So instead, we use more of a eye shape, like the pointy oval. So That then has on top of it this thermo, this waste heat generator. See, these are micro linear generators to nano-sized linear generators. And because I have this technique, I can easily make them. It's not that hard. But that generating is a nitinol with a piezoelectric, iron nitrate, and a copper coil. Okay, now the pressurized fluid, which is low pressure, which happens to have a supercritical pressure fluid that's inside the low pressure fluid, and then a gaseous fluid that is trapped like soda bubbles inside of it. That's typically what I always seem to go with. It's really rather efficient at capturing heat and densifying it, but then allowing for its expansion to be maximized because we want thermosiphon effects and wicking thermosiphon effects for the return because we also have to have it underneath. Now, the underneath is fine, the above is fine. Basically, we just allow for the above to help the underneath turn into its own version of a thermosiphon effect, as the bottom will push it up and the top will then reheat it, and then it collapses and it goes back up using wicking or gravitational effects accordingly. Okay, now that expansion of the fluid, because it's a liquid, is going to go into a nitinol wire, kind of like a spring. Now, nitinol, when heated up, goes back to its original shape. And so when it expands, it gets pressed, but then it's colder on one side than the other side. And so as it cools off and it's heated up on one side, it then expands and then goes back to that side in shape. And so it basically creates a spring. In its own right is also electrically conductive and creates, as a result of it being attached to the linear generator, that moves the magnet through that copper coil, and then those nitinol wires are on little tiny hinges. Hinges kind of style. It's a real, it's a hinge, more or less. I can't really call it anything other than a hinge, truthfully. A torsional bar, more or less. Like a spring, like they used to have in the gull-wing doors on, the what was that car called for Back to the Future? Has DMC on it or something. Anyways, that car. Anyways, it's a spring that then, will go back. And so that's a piezoelectric that then squeezes and, mechanically gets stressed and creates electricity in its own right. So as the expansion of the gas goes up to fill the volume that's there, it then goes off into another area, which is a secondary version for the other linear generator next to it, diagonally speaking. So as it expands, it goes off into that, but then it's also adding its expansion to already there expanding. And so these areas for the on top of for the iron nitrate magnet, that is connected, okay, to essentially piston. It's a rod. That's all it is. It's a rod. So anyways, that'll close it off as it gets expanded off on one side, but then it gets cooled on one side, and then it'll go back to its original shape, and it uses that mechanical strap. And then that closes off one side, opens up this, and then that'll heat up and expand, and you see the cycle repeat itself. Well, that goes off into another area that's diagonally associated with it that is also open, that then flows that energy into it and increases its, because it's further away from the source of heat, its energy potential into the linear generation action. You could only do that so many times, and so we have effectively a bunch of vents, which are exhaust manifolds that go off to the hollow vapor chamber design for the heat sink fins. that then are capillarily, not really capillary, but anyways, snaked through. So they start at a certain size and volume, and then they go into a larger size and volume. And the reason for that is that means it's lower pressure there, because as it compresses as a result of losing heat, it then has lower pressure for it to fill up this volume. That volume then acts as pressure as it's dense to the volume that it goes into for the reservoir at the bottom or the middle, respectively, as it uses the heat and pressure to pressurize that top, push it into the reservoir, and then into the space for this linear generation and piezoelectric generation waste heat design. Now, we're not completely finished. Almost, though. So, we have to use field effects because wires are annoying and they suck. And this vapor needs to transfer some more of its heat over a decent amount of distance, okay, in terms of depth and width. But because we have the eye kind of thing, and because we can channel it through and have very decent fin density, that allows for us, even though it transfers heat rather slowly, even with an increased surface area and mating process of the 3D printing design we have, it still will take some time, which is fine. Honestly, we're not expecting it to need to handle something like hundreds of thousands of degrees or even suddenly a burst of tens of thousands. So, as a result, this width and fin density creates a degree of boundary layer efficiencies that we can allow for with channeling, groove, and bump and dimple designs, which creates a laminar flow that skips like a Tesla through, that creates vortexes that then get captured and then brought out as a Venturi effect occurs to those vortex Tesla-like designs. It will look from the outside like it's too dense and it has too much pressure overhead, but once the boundary has been broken, it then increases its efficiency of allowing for air to pass through more and more readily, which in layman's terms means cargo forward become easier for air to go through. Pretty much. And as a result, there is also a potentiation of IR. So IR is usually not very well absorbed by light. I mean, by the air that we breathe, not light. Now, as that doesn't really have a chance to not still do that, you know what I mean? Like, it's not going to suddenly like super potentiate AR, retrieval and dumpage into, the air we breathe. For me, it turns into instead that IR creates a light wave interaction, which creates a IR that isn't IR. Okay, it's IR that's waiting to effectively light wave interact just after the ends of the rear of the radiator. Now, it then diffuses, it cancels, and then turns into a weird red sort of kind of there glow. It's a real like actual thing. It turns the air that's going through into a lens, and then it allows for a oscillation and resonance of the light and the wind, meaning air, going through to allow for this interaction after, typically, or just on the very edge of those fins. And so then it dumps that heat energy into the air slightly. It's more of, when I say that, it's like, it sounds like a whole bunch of what, and it's kind of basically what that is. So the light waves don't interact until the end because they create a resonance. Okay, and so that resonance then turns into a harmonic, which then allows for the light wave interactions to break down. But of course, while we have red light and everything, it's not very interactive. Okay, it's very directed. Okay, but a way to put it is that I grab that energy, the light wave energy, and that resonance, like I was talking about earlier with the materials that we were talking about. It turns that light wave into a superpositional kind of thing. It's a Lemke principle, as I've coined it. It's a superposition of a superposition, an entangling of an entangle, an entangling of a superposition, which is a very weird concept because it basically draws more in. But instead of drawing it from our fields now, it's just drawing it from more IR as it goes through the fins. And then it drops it into our atmosphere, effectively, or regular, oxygen, nitrogen, argon, hydrogens, all that. The reason why I say it doesn't really have light that interacts with it is because it doesn't really. It really doesn't. The light that it was a superposition and everything does, but it's not necessarily even technically there. It just added that heat and energy into that superposition and entangling, which then crashed out into those atoms and molecules. Okay? But the rest of the light was just that regular IR. And so, like, IR doesn't really interact much at all. So that's why it's very basic. You know what I mean? It's like, it's a very basic design. We already have these studies that show that this is the interaction profile of these things. I just talked about them. And as a result of the other light wave, superposition, which is a caveat. It's an asterisk quotations. I call it the Bernoulli's principle of quantum physics, my principle, because it's the Lemke principle, because it's acting like a Bernoulli's principle. It creates those interactions and forces them to more or less become kind of superpositioned, but they're not really. You see, they're not even technically not a thing. You know what I mean? It's not like they canceled out. This is the problem I think a lot of people would have with what I'm saying that don't understand quantum physics. Quantum physics means that the light turned into a wave function, and the wave function got entangled in such a way and interacted in a very, very specific sequence and resonance that extended its length and duration. But that, because it's in a chamber design here, that allows for those light wave interactions to ultimately amplify those wave frequencies and fluctuations to be seen as more or less greater degrees of energy than you normally would have. And so it dumps its energy into sustaining it and then creating a greater amount of energy in that sustained wave fluctuation resonance frequency thing that it's doing. Then it interacts with itself, using the lensing and the trailing off pattern of the air we breathe into the rest of the air as it combines. So think like little vortex and then like straight laminar flows that then combine and create a very specific pattern after trailing off of the fins. That allows for those fluctuations of waves that are potentials now and are superpositional in their own right, but they're not really. See, that's the thing. I don't say it's superpositional, but other people will try and describe it to a regular person as if it is, but it's not. So that's why I describe it to regular people that are most likely going to be listening to this. It's not superpositional. And it's also not entangled in any way, but it's kind of like the same idea. So, anyways, they interact with themselves, and then they crash that out into effectively all of the air that's there. Heating it up turns it into a potential, meaning a potential, then to kinetic, and then now heat. So that's what it's doing. It's a rather roundabout way of explaining, hey, so I basically shine light really well, and then it makes heat go into air that normally don't go into air. So that's all it's really doing. But it's like, if anybody talks to me like that's not a big thing because I'm kind of like blasé about it, it's actually an incredibly important and insanely impressive thing to do that. We have some of those things already accounted for. And by some of them, I mean every single piece of this process. It's already a known thing that can be done. Not so much in terms of it's been done before, not so much that it actually has a name as far as I'm aware. In fact, it doesn't. Because if you don't know, the wave travels resonantly towards the front where it starts with IR energy coming out. And so it creates what is essentially a rod almost that is resonating with inside of itself by tapping itself appropriately to create a combination of a wave, pressure wave that's inside of itself. But that's a real layman's way of explaining I'm kind of creating a technicality superposition, which means I'm superpositioning a superposition, and I'm entangling an entangle, and I'm superpositioning an entangle, and I'm entangling a superposition. All at once, more or less. And I'm extending it by using phasing and resonating in harmonics for the waves to increase its duration over time and its interactive profile in a very, very specific area after the rear that just dumps heat into it. It creates a potential. It's literally that. It's like, okay, as I dump the energy in, it then interacts and pushes onto things, but not really the way you might expect. It has to have that air that we breathe and the light crash in and dump that energy into something. And so if it doesn't have that air trail off the right way, creating that lensing effect, creating the interactive profile and wave fluctuation interactions with the air there, then it doesn't do it. It doesn't do it at all. But once it does do that, then it creates heat. It dumps the heat into the air, which is not actually what a regular person might assume it is, which is I change the wave frequency of light to interact with air. That is actually not what we're doing. Yeah, I know. It's like, no, that's how I want to explain it. And I'm like, yeah, I don't really care. It's not what's happening. It means nothing to me what you say, because that's not what that is. You sound like an idiot that wants to explain something incorrectly to a bunch of people that are going to misunderstand what is actually occurring in physics. It's not changing its frequency in any capacity. It remains the same IR, not AR, until it interacts. No, it doesn't. See what I mean? Like, that's what they'll until it gets to this point. I can already see the comment. If they ever see it, they ever listen to this, if they ever freaking comment, I can already see the comment. Doesn't change any at all, but it does create pincers, more or less, for the air that's there, lensed this light towards, and then diffused the light, and then allows for the splitting of a polarizational light that then is also now quantumly slot experimented off of the trailing fins, because of course they need to create those straight lines and vortexes that combine, which also creates a degree of pressure, which then alters its direction, creating a lens. Now, as they bounce and diffuse towards these centers, while the outside, not really, but the inside, a lot. You have a lot, like a lot. So what that means is these waves come in with diffusal properties that also come in that then are also resonant and harmonic to the point where they are a superposition of a superposition, which is a layman's term. It's not superpositioning. There's no superposition that's actually occurred, which I know. I hate the sound of that, right? But it's like, I don't really know what they call it. That's why I call it a Lemke principle, because to me, it's a Bernoulli's-Lemke's principle for waveguide interactive forces that are also carrying themselves more or less towards one lamineering, coherenting fashion that also allows for that wave to travel backwards, interact, and start another beginning of that. It's pretty cool, actually. But the point is, it's like a superposition, but it's not. It's like a superposition of a superposition, but of course it's not. And it's like it's entangled, and of course it isn't. And then it's like it's an entanglement of a superposition and entanglement, but it isn't. There's none of that going on. But that's why I call it frequencies. And you see this with pressure waves. That's why I call it harmonics and resonance, coherencing, and all the rest of that. Because I can totally see that in pressure waves. In fact, we use that for sound waves to effectively push them further and or concentrate and or even change their frequency and pitch and where they interact within a given diaphragm size or area that's enclosed, or so on and so forth. I'm just doing it with light. Okay, now as they cross towards this area, which has high concentrations of very laminered, but also very coherented air. Okay, so it's laminear, but laminear just means they're all heading in one direction, but they don't wave. Okay, so we have a pressure wave fluctuation that goes very specifically with the light waves that are going to go into it, which means as it goes one direction, it increases because of the blue shifting effect, interactive profile, but we're not creating a change in the light waves, just the accelerational parameters of the air. But that light wave creates a pincer. As it changes its oscillation, it also creates a change in the way light propagates through. Now, as the light propagates through and diffuses through and interacts, it then combines and drops as it interacts into a singular wave that is traveling the same way in direction, sort of. It's not coherented. It's just the majority of it has sent itself one direction, but it diffuses pretty quickly after that. But the energy information that was stored, which isn't really information, but energy, meaning heat, that could be there, and IR that would have been there, so on and so forth, is now in there for the air, which pushes it as it crashes, as it creates a potential in that area of interaction, kind of like light tweezers in a way. But the area of interaction, light tweezer, whatever, is really just a bunch of these polarizational, diffused, and entangled kind of styles of light waves that are all very, very bunched up. But they're not superpositioned. They're just very high luminosity. Kind of. You know what I mean? Like, that's why when I look at it, I don't see this photon or wave. To me, it turns into it's a bunch of field pressure waves. That's literally all that is to me. It's a bunch of freaking field pressure waves. And so that creates this field pressure wave that literally squeezes the air. But then it doesn't. You see, as it crashes, it squeezes and then it, like a rocket, kind of burns this pressure wave slowly over time together with the remainder of the air that's there. And so as it accelerates and extends, it then creates a version of, interaction throughout it that starts to space it out more and more. And so I see another version of these oscillations within inside of that area that then diffuse out as a red light slash just heat, more or less. They vibrate them a lot. That kind of thing. And so that's all it's doing. That's it. I mean it. It's like that's literally what it looks like. If you were to look at it with all the right little doohickeys, you could see it like that. I know, doohickeys. To me, it's not lasers. To me, it's a bunch of fields. It's a bunch of electromagnetic fields that I would just place and position in there, and then use the charge differences, and then a regular, because we have regular natural light, and so there are clear pressure differences. So it's just set up that light thingy that they do to see pressure differences, and Bob's your uncle. Now you have exactingly precise ways of seeing what's happening as a pressure wave function. That also happens to give you the effect of what is electromagnetically occurring, because the air itself and the light itself is now interacting and changing the field that is there for the electromagnetic field. Now, of course, you have to make it rather, specific in certain areas. You have to set it up so that way it's not going to destroy what is going on with it. But you get it close enough and you do the whole thing, it's like, yeah, no, it's not disturbing it. And so you still see what's going on pressure wise, and you still see the electromagnetics of the light and the ultimate interactive forces of the charges, right? No, not charges. Although I suppose that's a way to put that. But no, I'm not using charges. There's no charges going on. Nothing charge field, positive, negative, nothing of that nature. It's just a pressure wave. That's literally all it is. It's a crashing out of a like quotation marks, which isn't like quotation marks. I can already hear it's no, it's not superpositional. It's not a superposition of a superposition. It's similar in concept, but not the same at all. Okay? You have to remember that part. It's just a light wave that's done its best to interact appropriately with the air in the correct way so that as it basically interacts, it does so in a manner that bleeds its energy into the molecule or atom, respectively. That's all it is. Literally that, which is the electron orbital. Okay, to put it in perspective, it's an electron orbital interaction. It's not the nucleus of the atom at all. It's an electron orbital, which is not a charge field, because electromagnetics can interact with electron orbitals, and then they can dump their energy into the electron orbital. And to put that into an easy way to understand, if an electron moves in its orbital and it produces light, if light hits an electron orbital, then it will produce the opposite effect of pushing and creating potential, which now means we have kinetic. That is why it is a potential interaction. I kept saying potential. They apparently don't understand electrodynamics. They especially don't understand thermodynamics, and they certainly don't understand anything to do with quantum physics if they don't know what the hell a potential interaction is. So, if they thought it wouldn't work, they need to be quiet. They're not even in Physics 101 yet, which this is Physics 101 tech. Now, that's all that does. It changes the amount of heat that is lost from this design for the radiator, which produces a darn good amount of electricity. Quite a dang good amount, especially for the size. And so, wait, hold your horses. Remember that whole, plastic that's aligned, perpendicularly? Well, because it goes through in its interaction force the entire solar panel, when appropriately aligned, meaning lensed more or less and angled appropriately, it then goes into this radiator. This radiator then gains a electromagnetic advantage and a field effect advantage and a charge field advantage. So we're not gaining energy from nothing. It's coming from light. But that light gets dumped into making it easier to make electrons from these linear generations and piezoelectric generations of energy. It's a pretty sizable amount. It overtakes the amount of energy lost for the, one type of fluid to another. So there you go. It overtakes that by about 12% at most from my calculations. It's a small amount. It's really more of you probably see about 2 to maybe 5, but over what you lose for the conversion process. But do it really, really super nice and you focus it and all that, you can get up to that 12 or maybe more if you get the right materials and stuff. So, but point is, the very least, it's trying to add something back to it. So it's like a solar panel for radio waves almost. It's small. Remember, it doesn't really even work unless you happen to have heat making it happen. That's the biggest caveat to that. You can't just put it there and it'll do it. You have to have heat that's running and creating those small amount of electricity, which actually, because there's a large amount of them, and then they all combine in series and parallels, then they create quite a bit of electricity from waste heat. Now, that then gets added with this. If it doesn't have that, solar panel thing, then ultimately it just, if it's not making electrons to begin with, it just doesn't make it easier. And so it's not it won't do it at all. You know what I mean? Like it needs to be doing it to be able to make it work. That kind of thing. Because it has energy there, but it needs enough energy to cross the threshold, like the band gap, to then create an electron. And so when it does that, it now might get 2, maybe 3, that kind of thing. So that's why that works that way. But the flip side and caveat to even that is that's kind of difficult to align. So there might be a way to do it, but that kind of thing. I don't really specify it. To me, it's for the car design, and we started this off like why it can't be used for plasma for like a jet engine or something. And so we're finally nearly there because I have to describe this to someone to be able to have them even understand what the hell it is I'm talking about and why it works and how it works and what the principles are and what the basis of physics is and how the compounds interact and all the rest of it. So this is supposed to be attached to my engine, which is a literal electromagnetic charge field, attractive, repulsive electromagnetic engine, all in one. But it uses this vacuum, design that creates a vacuum along the blades and in the inside area in between the counter-rotating blades. As a result, it acts like a suctioning force as it tries to go back, but because there's blades in the way and because there's other blades in the way, it basically doesn't ever allow for it to ever fill that gap. And it skips off and it creates a degree of efficiency and a degree of increased energy potential because it's like a Stirling effect because there's a certain amount of pressure in our atmosphere, and then as it continues to move faster and faster through the blade profiles in this electromotor, actually, it then creates a measurable degree of increased speed, meaning velocity of air, which increases density again, which increases, again, that gaps for its vacuum potential, which creates a greater and greater and greater and greater until you get a near perfect vacuum created. It will not at all continue forever. You can only get to a near perfect vacuum, and no matter what, there's only so fast you can make air go through a turbine. Okay, then again, of course, again, you need a certain amount of air to start it, meaning wind, meaning you need energy to start the darn thing, and then if it ever dies down, if it doesn't have the correct shroud and everything to continuously draw air in and make this work, it will eventually slow down. And even with the shroud, it will again eventually slow down and stop. So it's not perpetual. It's just not. Okay. It will act like a flywheel, as I said. It basically creates a degree of potential energy that will slowly but surely get refilled back in, provided the air is slowed down, because that's its battery. That battery will then eventually slow down. And so, it's one of those things. Because some people will most likely try and get a big old funnel in front of it, some kind, and make it continuously work through. It's more of a plenum volume at that point, which then turns itself into its own battery, and it takes energy from the vacuum to be able to get that air to move. So there's a balancing act, and yes, eventually, because we have an atmosphere, and so there's pressure, it will keep itself going so long in provided as the friction does not exceed the limitations of the air coming in and the result of torque placed upon the windmill. Okay, so it's in no way, shape, or form getting it from nowhere. We have the sun and we have our atmosphere. It's getting it from the sun and the atmosphere in a vacuum. In a vacuum. That vacuum has to be maintained. it's a very specific blade angle and shape and a whole bunch of other stuff that makes it trail along and ultimately do this kind of interaction. And again, it's a Stirling effect. So the higher degree of heat and the higher amount of speed of air and the larger, there's always a balance, but it doesn't run forever. I know people really want it to be said that it will. It does not. Things will break down. There is a significant amount of energy in our air just in general. And so you should get a large amount of torque for a good amount of time. And truthfully, it should keep itself going for almost forever, quotation marks. It's not forever, and it's really just dependent on the heat, the wind of the day, yada, 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 yada. And it will eventually slow down. Like, that is the biggest caveat to this. It will eventually wear out for either bearings or tolerances or just even the air itself just stalling for some darn reason. Too much water, whatever, I don't know. But it won't work indefinitely. But it will work for a really long time. In two varying degrees of actual, like, energy gain. But the reason why I talk about it is because those fan blades and that pocket of energy in the hub axle area and the shroud are all charge fields and electromagnetic repulsive fields. So charge fields can be attractive with electromagnetics, but also with their own selves by being negative and positives. That also creates, with the electromagnetic repulsive technology that we all have, coils, it creates a stronger directed pull and push effect that is very able to be highly, highly okay, so I look at it like they talked about for scopes for degrees of increments called mils for like being able to land a shot. And so it's this little small amount of change over a small area, distance, that kind of thing. Then also precision and accuracy of the overall amount of torque that is there, which can be extraordinarily small for what it's worth, or wide, or my version, which is wide and small together, that creates a medium that's in between as it trails off. And so as the air gets pushed through, we push it into the battery. The battery then creates that heat. As it gets cooled off, it cools off, it squeezes, expands, squeezes, expands, squeezes, expands. It also happens to have a large degree of flow, but when done appropriately with the right valving, okay, and the correct blade that's attached to it, because of course that means we can create a pressure version instead of a high flow rate, which would be for like flying an aircraft. It's now for high pressure, which shoves air through this in a much more consistent manner. Okay, and that air itself also tends to carry away some heat, which I'm fine with, because it typically will generate very large amounts of electricity, especially when the electron flow goes into the solar panel and the linear generators, along with the air itself. And so it creates a very decent electron flow battery with heat that also produces more electricity. And you see the cycle, build. And there's not necessarily a runaway effect. There is a zenith point where it can no longer take more air through, or more specifically for me, it's more about the fact that I don't have the ability to have more surface area for either the solar panels or the radiator or the battery, which is actually more of a capacitor dumping into the battery. And so it generates electricity. by the piezoelectrics, the waste heat generator, and the solar panel. But just the battery alone, having air run through it, will allow for the fan electric motor combo to run and produce enough to move a whole car, while on top of that, still being able to keep itself operating at its regular battery potential for a very, very long time, if not actually start to charge itself, provided the rolling resistance, air resistance, there's enough water, there's enough, stuff for it to effectively make this electron flow and release of electron increase occur. It all is a very caveat-y kind of thing because it's like that electricity generation is within the 500 at most kilowatt range for a given size battery that is fairly large. Like the size of, I'm a 6'4" guy. I have a fairly large chest. We'll say the standard inline four, let's go with 1.5, maybe 1.2 liter sized engine. A battery roughly that in terms of length, width, but not height. So height is then going to be roughly the equivalent of about 3-ish, maybe 2-inch, really inches, and it should produce that up to those figures of electricity generation only when rolling and only when the fan is going, which, I mean, because you're moving, so it should, and you are draining electricity to do that. So as you use electricity from the battery itself, that moves the electric motor. That starts also moving air through, but it also starts making it easier to move air through because your car is now moving through. And then you have the waste heat generator and the solar panel, which just adds to the effect, is what usually most people will say. But for me, it's like actually the solar panel, the waste heat generator, and the battery itself is actually a huge capacitor. So it drains the capacitor for the time that you are starting your acceleration, and it will do it quite quickly, but it has a large capacitive because it's like a huge surface area. It's all down to micros sizes of compound areas for the capacitor field differences. Now, that dumps into and moves your electric motor. Okay, does it fairly efficiently, but it's not doing its vacuum just yet. It has to get there. Then, as you move forward with the car and the vehicle, it will start to do that more and more easily. As you are now cruising, let's say 65 miles per hour. Okay, not the average and everywhere, but here in where I live, it's the average for a lot of highway vehicle traffic. Okay, that 100% more or less, as long as you are within a proper following distance of a car in front of you, or a truck, or a semi. As long as you are not going to extremely high slope angles, and so long as it is not over 120 degrees Fahrenheit and at least 40% humidity, will charge itself. So, with a regular looking vehicle, not like a Tesla, more like, think old school 60s Charger style vehicle, which were not the most aerodynamic. So, there you go. And that's what that is. But the biggest caveats for a lot of people is they're not made yet. We have to do the thing, and so on and so forth. But from my calculations and my step by step, thinking it through, from what I know on everything that I can know about for the potentials, for the surface areas, for the given parameters of storage that should be there, the result of reduction of resistance, all this stuff, it should produce more energy to uh, to the cost of energy provided to move it. Now, regardless, in a lot of ways, for me, that is a cool, nice little trick, but it will not in any way get around the fact the higher altitude, the lower the humidity, it performs less. And so we're talking 150 to maybe 250 at most, depending on the speed of electricity generation, kilowatts, which usually, because of the amount of energy required to make the darn thing move, means that it's not quite as efficient, but it should, if you had the right aerodynamics, rolling resistance, everything else accounted for, still add energy. Again, the caveat is not all the time, and certainly you have to slow down, and then on top of that, aerodynamic resistance goes up, even if you're in a higher altitude. So there's always a balancing act in terms of physics when it comes down to that. It's about the fact that it's generating electricity from these interactions that are very, very efficiently done. That's what it's doing. So now people might ask about the beginning, which was why it cannot be used for a plasma generation, because it's an electron flow battery. Electrons are ripped out. They have to go into something. Maybe we have a prop like the fan that we're talking about, and then they just aren't added back in. And it's like, yeah. So that's an incredibly negative charge. It didn't make a plasma. And so, unless you happen to have the correct corralling fields of charge to a point in electromagnetics, specifically more than anything, but charge can help, uh, then it will rapidly try and add itself to anything, more or less. Which, if you have regular air, it could be an exothermic reaction, kind of, like, because we're ionizing what it is that's going through. And if you do it correctly spaced, there's this thing called heat. I don't know if you've ever heard of it, but it's kinetic movement of stuff. That's all it's ever been. But the problem isn't that it's not kinetically moving fast enough. It's that this heat is going into the battery itself, and it needs to be cooled down. Not to mention the gas that is now a very negative charge, which is going to be then excited by, most likely, the electrons you're going to use to turn into photons, and then some electromagnetic fields to accelerate and heat it up further. Then you need to hit it again with more electron reduction to really solidify it as a plasma, which means another material that can handle this, which is not this material. So first off, the battery is already gone now. But after that, it's then not really as plasma as a plasma you think could be. Okay. A good way to describe this is much more along the lines of, I have a plasma that is now extraordinarily and annoyingly trying to interact with even its own self, because there are other plasma there. And then on top of it, it dumps most of its energy very quickly into trying to immediately grab electrons. It might even create its own, truthfully, depending on how you have it enter into the atmosphere. See, the reason why I use electrodes and then excite it to ionize, but not really ionize, is effectively creating a plasma that's a different type plasma than this, that then gets fired after heated up, is way easier than like trying to create a plasma by ripping electrons out really, really simply, than like just dumping those electrons and not ever allowing for them to go back into something else. You know what I mean? That then has this get excited and then accelerated in such a way that then once it goes through another version, which again rips more electrons out for its second stage, and then further heats it up and potentiates it, and then will allow for air to come in. The actual for the weight that is that design, which I was saying before I started recording this to myself, is too damn high. You have like this plasma that's in this atmosphere, which it's hot, it's plasma, it's accelerated, but it's not like a whole heck of a lot of thrust. It's not a lot of thrust. It's really not a lot of thrust. And so as you get up to higher and higher atmospheres, well, there's less and less there for you to use. And so plasma seems like it might make sense if you do it like that. It does not make sense actually to do it like that. The given amount of thrust is very low, extraordinarily low. Plasma is less dense. I have to accelerate it much, much faster, which makes a lot more energy necessary to accelerate it. And then on top of that, because I am not combining it with the air, possibly if I do, it still needs to have a bell end, and the bell end is drag in its own right and more weight. And so then it turns into a cost of drag, weight, lift, thrust, balancing alongside of total amounts of energy necessary for it to do its job. Which the energy, while it's highly efficient for the thrust it has, in fact, quite possibly some of the most efficient, period, it has next to no real actual thrust for its given weight, its given drag, and its given density, because we are stripping things away. We are not adding things, and we are only adding things that are already there. My other designs create plasma that strip things away, but then effectively combine it with fuel and air and crash it into that, thus allowing us to also dump some of that energy from those stripped away electrons into continuing to suck in air and add in, more or less changes for the shape, meaning protrusions will protrude out instead of staying in, or a shape and change of the wing, sort of stuff, more or less. There's a various degrees of what we use it for. My main one after that's done is just grabbing air and using the velocity we have and the extremely high degree of IR admittance that we can achieve, and compression as well, to create, along with the relatively low atmosphere, which is still cold, but it's also relatively less dense, but because we're traveling so fast, it does ultimately act like a bit of a heat sink, a way to compress air, filter it, and then gain some oxygen for our space travels, and or just regular nitrogen, whatever really that we can then use as a way to sort of add ourselves back in to the atmosphere and still gain some thrust and achieve some measurable amount of continuation of efficiency for the given design, because I'm now needing less fuel because I know I will get fuel at the upper atmosphere. So I can now save for fuel and then burn that when I'm back in and use gliding techniques more or less to get to where I need to, which is now skipping out of the atmosphere slash low orbit that then allows for us to burn and then enter orbit. So that is why I chose those designs, because those designs are very efficient for that. But the other design for plasma, while it can be achieved and you can get measurable amounts of thrust, in fact, incredibly good thrust, but not orbiting thrust. It's kind of like a really shitty thing to say to most people because it's like, this seems so cool. But it's like, eh, it's really heavy. Like, it's really pretty heavy. For like the other designs I have, it's like, it's really fairly phenomenally heavy compared to that. And the amount of thrust that you get out of it is not significant. And then you have to design an entirely different airplane, which is feasible, and you can do it. And you can even achieve a small amount of out of our atmosphere into space travel with it. Orbit is not necessarily something you can do. And then on top of that, the fuel you burn, because the engine's like that, you can't use that engine now. And so, in the turboprop, which almost what it is, tends to make it so that way it's kind of useless. But for this one, I can throw the gas by closing off that, a little bit, and then injecting gas into the front, and as it runs through, it, even though it doesn't have much of any atmosphere at all, or any atmosphere, it's not necessary. I allow for it to combine and create those vacuums still, and then create a spark, and then the continuation of thrust, thus potentiating its effect out of the atmosphere, which is a good thing. And I can still make plasma and still use that plasma. And so, like, plasma just by itself can work. And there is a additive, meaning you can just simply push fuel into the bell end or near it, and you can get your thrust. But the reason why is it's just not a lot of thrust. Like, that's going to get you a genuine space plane. You know what I mean? That other design is a space plane. This one is a very high efficient, but very low orbit at most, and especially low weight space plane at most. Which, if I'm being really brute force, just direct, honest, it's not going to get you much more than a plane with a small amount of cargo. Okay, that for the given actual energy that you used, meaning the batteries and the stored battery and because you need that. And even with my cool idea for a plane that has like all this stuff on it that I'll get into later, not on this. This has already gone on too long. Um, happens to be just a really rough thing to suggest for someone to do. It's wonderful, if I'm being honest, for not space planes. It's literally like, don't ever use it for a space plane because like the energy you use is more and greater than the energy I use for this space plane design outright. It's that much more efficient at what it does because of the energy recapture, because of the speed, because of the overall fuel use and reuse, effectively mitigating the weight that has that you have to keep. And so like that makes more efficiency, especially on a reentry, because then as I come in, the way the air is allowed to go through, it then compresses itself, making its own version of a ram air and truly Bernoulli's principle type effect, which is very efficient because I can use some nitrogen and some oxygen, which is just regular air, and dump it in, and that creates nitric dioxides, which often will explosively decompose and then gain me thrust, which I cannot really use for the plasma at all. I can use somewhat of that, but that doesn't even have it's the worst because it's like I talked about this in one of my other videos, but it's like it's literally just a bunch of parabolic styles of exhaust. Once it burns a little bit, it starts to push one direction, pulls more air in, and then it compresses, but then creates these vortex. And point is, it sucks more air in. As it sucks more air in, I can burn more fuel, and then eventually it hits a point where it's going so fast for the air that's sucked in that it's essentially doing its own version of the intake for a jet engine. Now it takes a certain amount of air to get it going, decent amount of fuel. If it has very low air, and so like I have a propeller that's internal, that's more of a compressor that blows air in and then through the sides and then mixes some fuel and burns. But you don't technically need that because if you have a big old fan or a wall of fans that blows air in, it'll do it by itself that way. So as I re-enter, I don't have any moving parts that can break, that kind of thing. But I don't think it's wrong for someone to want to use it for that plasmification. I just don't think it's very effective and efficient. Still will get the job done. It will still work for the given amount of energy used and not gained back, and the overall weight that is now there, because you have these batteries that have to be there and props that you have to use, materials, so on. For costs, I don't find it maybe possibly as effective and efficient as the other design that I have. Try if you want to think about it. I didn't after a certain point because I was like, well, it has less, it does more with less, and I feel like it's easier to manufacture. So I don't know, but give it a shot, give it a whirl. Truthfully, I was already like super in the past annoyed with the whole idea, trying to use it for plasmification because I wanted to try and use plasmification compression structures to try and elicit some level of increased heat and density and velocity gained alongside of a resonance, like I was talking about with photons, pressure waves inside of a cylinder that had the right setup for it. and then entering in electromagnetic charge fields for repulsion and attractive forces for the plasma, and then laser light, some kinetics, and some particle accelerated degrees of fusion to elicit a small amount of fusion that would then bloom as it got further towards the bell end, creating a genuine rocket engine that starts with a turboprop, more or less, that allowed for a degree of fusion. It's not ignition fusion. I have to constantly feed particle acceleration fusion seeds into the plasma to make it work. It has to be very fast moving, and they effectively go against the grain to make this work, to slam in, and I have to create little pockets and moments in time, and some degrees of entangled superposition stuff, like I was saying earlier. But this time it's actually superposition. This time it's actually entangled. But they're using light waves and so on, or not. They are. I was using in the cylinder, the plasma and all that was creating that moment of increased likelihood of fusion that would then exit together with the rest of the captured heat energy in the plasma into the bell end. Then I would add in a large amount of air from the ram air that I usually had that would suck in a fuck ton of air and shove it into near the nozzle area of the bell end. So that way, in case there was an overpressure, or in case there needed to be some interactive chemical, or if there was some electrons, they just, that kind of thing. It's like, so there's electrons here that need to go back. So it's going to try and add itself in. And so I create like a cone that's essentially around that also allows for exothermic pressure to be exerted onto the bell end to atmospheric, and then I would allow for the heat to be dispersed, and then with that air to try and interact and combine in a more efficacious manner for that area, meaning it wouldn't try and attack my plane because my plane started getting hit with plasma. And so I had to shorten the freaking tail and bring the wings so far back to basically stop it from trying to hit me. And I started making like these, long oval shapes, the more or less like extra wings to try and dump the electrons back into the plasma. And then I was like, screw this. I'm making fusion to a point, and it's small. But small means a lot in terms of fusion, because a small amount of fusion goes a long way. It produces a lot of heat and energy. And so basically when I resonated that pressure wave as it fused and created I was able to gain a measurable degree of continuation with the particle accelerators, so on, of continued fusion. But it's not fusion. It's not a ignition fusion. It's fusion, but fusion with a twist. It mostly sends a large percentage of its pressure wave out one way, and a pressure wave that slows down and then gets hit with a ginormous amount of plasma, compressing and creating its own version of a spike wave when we do it properly. And it creates continuation of thrust. Instead of a pulse jet, it's a continuous thrust, which is great. I like that. It doesn't produce much in terms of actual fusion. It does produce a shit ton of heat, compression, and thrust for what it is and for what it was worth. The biggest caveat is weight, and the other biggest caveat is it only works inside the atmosphere and traveling at very high speeds. And so it was great for extremely high atmosphere, traveling very, very fast. We were talking above Mach 15. Although it would start the process well below around Mach. just very inefficiently. So it would do that. It just didn't do it very efficient, and boy, was it loud. Like it's a nuke going off. Levels of loud. It's not really, but it freaking feels like it. Like the pressure wave that it sends off the bell end is its own hypersonic almost pressure wave. I say almost because we have to measure, or we have to make the bell end the proper size for a atmosphere. And so it's a fairly large bell end, but then we have an aerospike, and then we have a extending bell end and a widening bell end, which again has that whole caveat of yeah, it's a lot of weight. And I have to allow for air to come in, and then it turned into I have a rotating piece that needs to capture air as it rotates out and then shove it into the extending bell end part that also widens, and so it turns into a flower, a literal kind of flower petal-ish design that allows for air to scoop in and in from the front, creating a mixture and then a pressure wave that is relatively well captured by the entirety of this very long, stupid flower shape, which isn't stupid. It's actually pretty cool. I'm not even gonna lie, it's actually really pretty cool. We even have like a little aerospike that's on the inside that tends to create its own winding and lengthening to allow for it to capture more effectively and efficiently the small amount of fusion going on. It's very weighty, costs a shit ton. It works within atmosphere. And then you don't really have a way to make it work quite so easily once you are in space, because the kinetic energy that was being added in as a result of the air that we're in being pushed against and added in such a way that makes that occur more readily, well, that ultimately kind of goes out the window when there is no atmosphere. I have to go pee, I have to go get my groceries, and that's basically why that didn't work, and that's kind of where I ended up at my design phase for my entirety of that battery thing. But that's where it ended. I didn't have a way of making it better, but other people have more knowledge and might be able to do something that I didn't. So there you go. But I don't feel like it could maybe be. But sometimes I'm wrong. So there you go.